Hi, everybody. Well, I guess the video from Monday didn't work out, so I'm gonna try to go through this again. I know it's late. I got the kids to bed, so this is my chance to do it. The With the experiment, I mean, yeah, it's supposed to be due tomorrow. I know many of you have done it already, but if you need some more time, that's fine. You can take some more time, or if you feel like you didn't do a great job at it because you didn't really understand or something like that, just take the time, redo it, and resubmit it when you get a chance. So with this lab and what I was hoping to go through on Monday, um, you are designing an experiment. And at this point in the semester, you've designed a lot of experiments. You've done at-home experiments. You've done other things from class that were more open-ended. But this is definitely the type of experiment that is not just follow the directions. You have to figure out what you're going to do, how you're going to measure these things, how you're going to set it up, how you're going to properly control your experiment, all of that. And because of that, it's a really good, I think it's a really good activity. All right, so you got these UV beads. There's little beads in there in your lab kit that absorb UV light and change color. They all are white, I believe, when they're not exposed to UV light, but then when UV light hits them, they change color. I think they were fairly randomly distributed, so you should have some perhaps different colors, and that might be something that you have to think about when it comes to things like controlling your results. Does one color react differently from another one? If you're doing something that's carefully timed, does a purple bead change faster than an orange bead or something like that? So you may need to take a look at that depending on what you've got. So the idea is, how can we block ultraviolet radiation coming from the sun? Now, ultraviolet radiation is invisible. We can't see it with our eyes. It is higher energy than visible light, and it is what's called ionizing radiation, which means that when it hits things, it can mess with the electrons. It can knock electrons off and do things. It has enough energy to do that. So that's one reason why it's so dangerous to us, is when it hits our skin, not just the surface layer, but pretty deep in there, it can knock electrons off of, for example, DNA, which can cause the DNA structure to change, and that affects how it's going to work and how it's going to encode for whatever it's supposed to be doing. And that's how UV light can cause things like cancers. This is true of all high energy radiation. X-rays, for example, gamma rays also have that possibility, but we tend not to be exposed to as many of those kinds of things. But we still take precautions. So like when you get dental X-rays, they put the lead thing on you to protect you from excess radiation. And if you were to, if you had some kind of a medical issue where you needed to get a lot of CT scans or chest X-rays or things like that, that would be carefully monitored so that you don't get too much X-ray radiation within a year. There's a safe level, and you have to just stay below that level. But the thing that's so dangerous about UV radiation is that we're always being exposed to it whenever we're outside or even inside. Some UV radiation can go through windows as well. So we have to be careful and protect ourselves from that light. So your job in this experiment is to figure out how can you protect yourself from UV light by using the beads as a measure of how much UV light is getting through various blocking things. So your blocking things could be things like different sunscreens. They could be fabrics, different kinds of clothing, even something like something hard, a piece of metal or something if you've got it, or plastic. So you can get a sense of how UV light penetrates through different types of materials. With sunscreens, there's two major classes of sunscreens. There's what's called physical sunscreens and chemical sunscreens. It's a little confusing because, of course, everything is a chemical. But sunscreens that contain titanium dioxide and zinc oxide, the way those work is those really small particles of those minerals, titanium dioxide and zinc oxide, are just simply reflect the UV light. So it's essentially like a little tiny grain of piece of rock, basically, and that bounces off the UV light. So when you make a thin coating of that over your skin, the UV light cannot penetrate it. If I don't know if anybody has seen like in old movies, sometimes like or maybe people still do it. I don't know. I don't know if people do. But when you have like the lifeguard with the white nose, because they have that like really thick zinc oxide barrier, and then that would prevent the rays from getting to your nose. Most sunscreens now are formulated in a way, even physical sunscreens, where you can't see them when they're on your skin. But if you use a lot of sunscreen, you'll notice that physical sunscreens with zinc oxide or titanium oxide tend to be harder to rub in. They take a lot more work before the white goes away, and that's because of those particles. Chemical sunscreens work a little bit differently. They have molecules that actually absorb the UV light. So the UV light hits the molecule, and the molecule absorbs the photon of energy and prevents it from going into your skin. So it's not reflecting it off, it's just absorbing it. And the molecule can actually be destroyed in that process. So those sunscreens with chemical names like avobenzone and things like that, those are more common, and even the physical sunscreens sometimes will have some of those in there as well. There's also different wavelengths of UV light, so you have to think about blocking UVA versus UVB. I don't know what the beads do. I don't know if they're more active to one or the other. We don't really have a good way of testing that unless for some reason you have a source of UVA or UVB radiation. But we're going to have to ignore that part for this experiment. So you want to test how these things behave, and you want to set up an experiment that works. So like this fourth bullet here, what are you going to measure to be able to compare how effective the different materials are at blocking UV light? So some ideas, you could, for instance, pick a time and just say, all right, after 20 minutes, I'm going to see if any of them have changed color. But that might be too short or too long. That's just a time that I picked. And it's going to depend. Maybe that's too long and everything's changed, so you can't really tell any difference. Maybe it's too short and nothing's changed. So maybe you want to monitor them for a certain amount of time, and kind of like monitor when things have changed. Also, how do you define change? When you look at the beads, if you do like a control where you just put the beads right out in the sun, you'll probably see that they don't immediately turn dark color, they kind of fade to that color. So are you going to try to measure the gradient where it's like light, like, on a scale of 1 to 10, how deep is the color? Or are you going to just say like how much time until it's all the way saturated? Those are all different choices that you have to make. And you may not be able to plan it right away in your notebook and then just carry it out and have it be great. You might plan it out and then go outside and do it and realize like, oh, that didn't really work at all. I couldn't tell the difference. I'm going to have to rethink this and then go back again. So if you have already done this without listening to this, and you had kind of that experience where it sort of worked, but like maybe not great, just go do some more tests. I assume you still have your beads. They're not destroyed in this experiment. You can wipe the sunscreen off of them or wash them off. Or, if you used fabrics and things, obviously that's not going to hurt them either. So, you can do this over and over again. So as you're developing your experiment, you can look at what's happening and then decide, you know what, that was too hard to tell. I couldn't figure out what was going on there. So I'm going to do it again. I'm going to do it a little bit differently. Right. So but the idea is by the end, you can really say this thing blocked it better than this, and this blocked better than this, and this blocked better than this. And then remember, another important part of science is reproducibility. So once you've got all those things dialed in, you've got to watch it for 11 minutes and, and whichever one's, and the control is going to change in 2 minutes. So if it gets to 11 minutes, then it's a good block or whatever it is. I'm just making up numbers. But once you've got that dialed in where you have a procedure that seems to do this, do it again. And this time, try to follow exactly what you wrote down as a procedure once you've developed it as a good procedure, and then do it again and do it again, or however many times you can, or enlist somebody else. Maybe somebody else in your family can follow your directions. If you've got kids around, they like doing this kind of stuff. That might be fun. And you can say, hey, can you reproduce my results, or do you get different results? You can talk to other people in class and see how your results compare. You can look at different brands of sunscreen, whatever. But the idea is that you set up this full experiment starting from just this basic idea of can you block UV light from getting to the beads, and then eventually getting to like a really good procedure where you've clearly shown the differences and reproducibly you're able to reproducibly get those results. And you know what? Another thing that makes reproducibility important is you may not be able to reproduce your results. So you may think you've got it all dialed in, and then you do it again and you get a different result. Like one sunscreen you think is better than the other, and then you do it again and the other one wins. And then you do it again and there's like some randomness there. That's okay. That may be a sign that something else is going on. Something else isn't being well controlled. Like um, well, one thing that's really difficult in this experiment, if you're using sunscreens, how do you get a consistent layer of sunscreen on the beads? You're either spraying them or rubbing cream on them or something, but there's going to be some variation there. So, keeping that uniform in every trial is going to be really tricky. You can kind of come up with some ideas of maybe how to do that, how to try to keep it consistent. But that's ultimately going to potentially be a problem. There's also the issue of control. What does it mean to have a control? Is the control always just the bare bead? I would say, depending on what you're doing, maybe not. So for example, what if it turns out that the actual cream itself can block UV light, not the SPF ingredient, not the actual sunscreen ingredient, but just some cream on the beads is enough to do that. If your control was just sunscreen versus bare bead, you wouldn't be able to tell. So another test might be to look at the sunscreen and then just take some other kind of a cream or soap or whatever, something that has the same consistency as the cream but is not sunscreen, maybe bug spray or something, something that has, if you're using spray sunscreen, maybe you use bug spray or a spray lotion of some sort. If you're using a cream sunscreen, maybe you use a hand cream that doesn't have any SPF kind of thing in it. So then you can see, is there anything else in those creams that's causing the UV light to be blocked? Or can we actually say that it's for sure the sunscreen type ingredient? All right, so then once you have gotten that kind of under control, the report should be pretty straightforward. So you've got this whole procedure worked out now. Describe it in detail, enough detail that someone else who's not you can reproduce your results. And ideally, test that. Find someone else who's not you and see if they can get your results. I know in this current situation, some of you don't have access to other people at the moment, but it's just an idea if you can do it. And then, what did you do? And then your argument. What did you find out? How can you protect yourself from exposure to UV light? Maybe you found out none of this stuff works. I feel like that might be a problem with the experiment because we know some things, but that might be something you learn. Maybe you found some old sunscreen in the bottom of your closet that's expired, and you want to test that against newer sunscreen and see if that actually matters that it's old. Those kinds of things can be an interesting test as well. And then when you support your answer, this very last part, this is important, it should be based on your own data. So what did you actually find out? I don't want to know like what people have published about sunscreens for this experiment. I want to know what you found out in this experiment. If you haven't done the article report for the scientific paper yet, and this is something that interests you, you could find some scientific reports on sunscreens and then use that just to get some more information about it and maybe inform your result. But your results for this experiment should be just, what did you do? What did you do on this? All right, so hopefully that all came through and recorded okay, and gives you a little bit more background as to what you should be doing for this experiment. Again, if you need some more time for it, that's okay. We are running out of time for the semester, so if there are other outstanding assignments from previous weeks that you haven't gotten in yet, please make sure you do that. The withdrawal deadline's coming up, and once we get close to the end of the semester, there just isn't enough time anymore to complete the work. So, if you're missing a lot of stuff, you've got a lot of zeros, and you come in like the last week of class and say, well, what do I need to do to pass? The answer is it's too late. You can't anymore because it's the end of the class. So I don't want that to happen. So if you've got, if you're mostly keeping up, but there's a couple outstanding things, just get them in, and then you should be okay. All right. Well, that's it for now. I'll be back here in the morning to go over the greenhouse gas stuff, the worksheet, and finish up the module and any other questions you have before you take the quiz. So I will see you in the morning. Bye.